Right now, beneath the murky waters of the Hudson River, a ticking time bomb is vibrating with the force of 200,000 people every single day. We are talking about two ancient, crumbling tubes of concrete and iron that serve as the only rail link between New York City and the rest of the American East Coast. If these tunnels fail, the economy of the United States doesn't just slow down, it hits a brick wall at 60 miles an hour. But after decades of political fighting, delays, and near-catastrophic damage, the most expensive and most important infrastructure project in North American history is finally happening. This is the $16 billion Gateway Tunnel, and it is a masterpiece of engineering that is being built in one of the most difficult environments on the planet. To understand why we are spending $16 billion on two holes in the ground, you have to realize that the current tunnels are over 110 years old. They were built in 1910 by the Pennsylvania Railroad using picks, shovels, and dynamite. At the time, they were a marvel. Today, they are a liability. They were never designed to handle the weight or the frequency of modern electric commuter trains. But the real turning point came in 2012 during Superstorm Sandy. Millions of gallons of corrosive salt water flooded the tunnels, soaking into the concrete and eating away at the electrical systems and the structural steel. Ever since that water retreated, the salt has been left behind, slowly crystallizing and causing the walls to crack from the inside out. Engineers have been patching them for a decade, but you can only patch a sinking ship for so long. The Gateway Project is the massive multi-decade plan to build a brand new, two-track tunnel under the Hudson River, and then, and only then, shut down the old ones for a total years-long overhaul. But calling it just a tunnel is like calling the International Space Station a tin can. This is a $16 billion surgical strike into some of the most complex geology in the world. Manhattan sits on a massive shelf of hard rock, but the riverbed itself is a chaotic mix of silt, clay, and glacial debris. To get from New Jersey into New York, the engineers have to navigate through all of it while staying deep enough to avoid the massive ships passing overhead, and shallow enough to connect with the existing rail yards. The stars of this show are the tunnel boring machines, or TBMs. These aren't just drills. They are mobile factories the size of 2 football fields. Imagine a rotating cutting head 5 stories tall, pushing through the earth with millions of pounds of force. As the machine grinds forward, it doesn't just leave a hole. It features a robotic vacuum system that pulls out the dirt, and a high-tech assembly line that installs the massive concrete segments of the tunnel wall behind it. By the time the TBM passes a certain point, the tunnel is already finished and structurally sound. But these machines are incredibly expensive to run. Every minute one of these giants is stalled, it costs thousands of dollars in labor and lost time. And under the Hudson, things always go wrong. One of the biggest challenges for the $16 billion plan is what engineers call the mixed face condition. This is when the top half of the drill is chewing through soft mud while the bottom half is hitting solid rock. This creates uneven pressure on the cutting head that can snap steel teeth like they were toothpicks. To combat this, the Gateway engineers are using a process called ground freezing in certain sections. They literally pump supercooled liquid through pipes into the ground, turning the soft mud into a solid block of ice. This allows the machines to cut through a consistent material, preventing the tunnel from collapsing or shifting during construction. It is an incredibly expensive and energy-intensive process, but when you are working beneath a river that carries massive cruise ships, you don't take risks. But let's talk about the money. $16 billion is an astronomical sum. To put it in perspective, you could build several Burj Khalifas for that price. So where is all that cash going? A huge chunk of it isn't even for the digging. It is for the staging and the massive new bridges that have to be built in New Jersey just to get the trains to the tunnel entrance. This includes the replacement of the Portal North Bridge, a notoriously unreliable swing bridge that often gets stuck in the open position. When it does, workers literally have to go out with sledgehammers to bash the rails back into alignment so trains can pass. Replacing that single bridge is a billion-dollar project on its own, and it is only one small part of the Gateway puzzle. The logistical nightmare of building in New York City cannot be overstated. You can't just park a fleet of construction trucks on a Manhattan street. Every piece of equipment, every segment of concrete, and every gallon of fuel has to be timed to the second to avoid paralyzing the city's traffic. The project requires a massive staging area on the west side of Manhattan, right next to the high-end developments of Hudson Yards. Engineers had to build a concrete casing beneath Hudson Yards years ago, just to preserve the path for the future tunnel, because if they hadn't, the skyscrapers would have blocked the route forever. That casing sat empty for years. A multi-hundred-million-dollar bet that the rest of the project would eventually get funded. For the people listening who don't live in the Northeast, you might wonder why your federal tax dollars are going into a hole in New York. The answer is simple. The Northeast Corridor is the most productive economic engine in the world. It generates 20% of the United States GDP. If these tunnels failed and the rail link was severed, the resulting congestion on the highways would cost the national economy over $100 million a day. Supply chains would buckle. Air travel would become even more chaotic as thousands of people flooded the regional airports. The Gateway Tunnel isn't a New York project. It is a national security project for the American economy. The construction also involves a massive underwater struggle. Deep beneath the river, the water pressure is immense. If there is a breach in the tunnel lining, the river would fill the tube in minutes. To prevent this, the TBMs are pressurized, meaning the workers inside the cutting head are actually living and working in a high-pressure environment similar to deep-sea divers. They have to go through decompression cycles just to go home at night. It is grueling, dangerous work that requires a level of expertise that only a few thousand people in the world possess. As we move deeper into the project, the focus shifts to the New York side. Manhattan is a labyrinth of existing infrastructure. There are subway lines, sewer pipes, electrical grids, and steam pipes everywhere. The new tunnel has to weave through this underground jungle without disturbing the foundations of 60-story buildings. Engineers use sensors that can detect movements as small as a fraction of a millimeter. If a building shifts even the tiniest amount, the sensors trigger an alarm that stops all work until the ground can be stabilized. It is like playing a game of Operation, but the stakes are billions of dollars and the safety of thousands of people. Another fascinating part of the $16 billion plan is the ventilation and safety systems. Modern tunnels have much stricter requirements than those built in 1910. The new gateway tubes will include massive ventilation shafts that can clear smoke in seconds in case of an emergency. They will also feature sidewalkways for easier evacuation and specialized fire suppression systems that didn't exist a century ago. These safety features take up a massive amount of space, which is why the new tunnels are significantly wider than the old ones, even though they carry the same size trains. Now let's consider the environmental impact. Moving people by electric train is one of the most sustainable ways to travel. By doubling the capacity under the Hudson, the Gateway project will potentially take tens of thousands of cars off the road every single day. This reduces carbon emissions and improves air quality for everyone in the region. But building the tunnel itself is an arc and heavy process. The sheer amount of concrete and steel required is staggering. To offset this, the project is looking at using low-carbon concrete mixes and recycling as much of the excavated soil as possible to create new parkland or industrial sites. What happens if we don't finish this in time? The old tunnels are on borrowed time. Every few months, another electrical fault or a chunk of falling concrete causes massive delays. We are currently in a race against the clock. The goal is to get the new tunnel open by the early 2030s. Once it is open, the old tunnels will be taken out of service one at a time for a total gut renovation. They will be stripped down to the bare rock. The salt-damaged concrete will be removed, and they will be rebuilt to modern standards. Only when that is done, around 2038, will the region finally have 4 working rail tracks under the river, doubling the capacity and providing a level of reliability that hasn't existed in our lifetimes. The sheer human effort involved in a project like this is hard to wrap your head around. At its peak, the project will employ thousands of union workers, from engineers and architects to laborers and specialized technicians. It is a massive job creator that will support families across 3 different states, but it is also a source of immense pride for the people working on it. They know they are building something that will last for the next century. They are following in the footsteps of the sandhogs who built the first tunnels, using modern technology to solve the same ancient problems of water and rock. The technology being used to monitor the project is also next generation. We are seeing the use of digital twins, which are highly accurate virtual models of the tunnel. Every sensor on the TBM and every piece of data from the ground monitors is fed into this model in real time. This allows engineers to run simulations and predict problems before they happen in the real world. If the machine is about to hit a pocket of loose soil, the digital twin will show the potential impact, allowing the operators to adjust the pressure or the speed of the machine in advance. This level of data-driven construction is what makes a $16 billion project actually feasible in such a high-risk environment. But there is also the political drama that has haunted this project for years. The tunnel was actually canceled once before, back in 2010, when several miles of work had already been completed. That cancellation is often cited as one of the biggest infrastructure blunders in American history, as it set the project back by more than a decade while the price tag continued to climb. The lesson learned from that era is that infrastructure shouldn't be a political football. These are generational assets that require consistent support regardless of who is in office. The current $16 billion funding agreement is a complex pact between the federal government and the states of New York and New Jersey, designed to ensure that no matter what happens in future elections, the tunnel keeps moving forward. As you listen to this, work is already happening on the ground. In New Jersey, the massive bridge supports for the new rail approaches are rising out of the meadowlands. In Manhattan, the final preparations are being made for the TBM launch sites. The project is no longer a dream or a political talking point. It is a reality of steel and concrete. It is the largest construction project in the Western Hemisphere, and it is happening right beneath one of the most crowded places on Earth. The complexity of the underwater work is worth diving into. To ensure the tunnel goes exactly where it's supposed to, engineers use high-precision GPS and laser guidance systems that can keep the TBM on track within an inch over several miles. Since GPS signals don't go through the water or the earth, they have to use a series of relay points and gyroscopes to keep the machine perfectly aligned. If the machine is off by even a fraction of a degree at the start, it could miss its mark on the other side by hundreds of feet. The level of math being done by the navigation teams is enough to make your head spin. And what about the waste? When you dig two massive tunnels under a river, you end up with millions of tons of mud and rock. This material can't just be dumped back into the river. It has to be loaded onto barges, transported to specialized facilities, tested for contaminants from a century of industrial pollution, and then repurposed. Some of it is used to cap old landfills, while some of the rock can be crushed and reused as aggregate for other construction projects. The logistics of moving this much material out of the center of New York City is a massive operation in its own right, requiring a dedicated fleet of barges and trucks. There is also the challenge of the power grid. These tunnels and the trains that run through them require an enormous amount of electricity. Part of the $16 billion is being spent on massive new power substations that can handle the load. These substations have to be built on flood-proof platforms to ensure that even if another superstorm hits, the trains keep moving. This focus on resiliency is a common theme throughout the project. We aren't just building for today's weather. We are building for the extreme weather of the next century. One of the most impressive feats is the construction of the Manhattan Tunnel entrance. Because the ground in that area is so soft and saturated with water, they are using a technique called slurry walls. They dig deep trenches and fill them with a dense clay liquid that keeps the trench from collapsing. Then they lower in massive cages of steel rebar and pour concrete from the bottom up, displacing the slurry. This creates a solid wall of reinforced concrete that goes all the way down to the bedrock, creating a dry box where the tunnel machines can safely enter and exit the island. As we look at the timeline, the next few years will be the most intense. The TBMs will be lowered into their launch shafts, and the slow, steady process of mining will begin. It is a 24-hour-a-day operation. The machines never stop. Teams of workers rotate in and out in shifts, living in a world of artificial light and mechanical noise. The sound of the TBM is a low-frequency rumble that you can feel in your chest more than you can hear with your ears. It is the sound of progress, but it is also a reminder of the sheer power required to move through the earth. The success of the Gateway project will be measured in decades. Most people today will only experience it as a smoother commute or fewer delays. They won't see the $16 billion engineering marvel that makes it all possible. But for the people who study megaprojects, Gateway is a landmark. It is proof that we can still take on massive, high-risk challenges. It shows that despite the cost and the difficulty, we are willing to invest in the future of our cities and our economy. What makes this project so compelling is the mix of the ancient and the futuristic. On one hand, you have workers using methods that haven't changed much in a century, like using heavy tools to secure bolts in a dark tunnel. On the other hand, you have autonomous sensors, AI-driven models, and robotic construction systems. It is where the history of New York meets its future. The original tunnels represent the ambition of the industrial age. The new tunnels represent the precision and the complexity of the digital age. As the TBMs eventually break through the bedrock on the Manhattan side, it will be a moment of massive celebration. It is known as the breakthrough, and it is a tradition in tunneling that marks the end of the most dangerous part of the job. But even after the tunnel is bored, there is still years of work to do. They have to install miles of track, overhead power lines, signaling systems, and communication cables. Everything has to be tested thousands of times before a single passenger train is allowed to pass through. The $16 billion price tag often leads to debates about whether it could have been done cheaper. In other countries, tunneling often costs much less per mile. But New York is a unique animal. The cost of labor is high, the regulations are strict, and the existing infrastructure is more dense than almost anywhere else. When you add in the cost of working under a major shipping channel and the need for extreme seismic and flood resiliency, the price starts to make sense. You aren't just paying for a tunnel, you are paying for the security of an entire region. For the commuters who have spent years stuck on a dead train in a dark tunnel, the Gateway project can't come fast enough. It is a symbol of hope for a more reliable future. It is about more than just getting to work on time. It's about the quality of life for millions of people. It's about being home for dinner instead of being stuck under the river for 3 hours because a piece of century-old wire snapped. This tunnel is also a massive case study in risk management. Every aspect of the $16 billion plan is designed to minimize the chance of a catastrophic failure. There are backup systems for the backup systems. If one power line fails, another takes over instantly. If one pump fails, 3 more are ready to go. This level of redundancy is expensive, but it is the only way to build a piece of infrastructure that is expected to last for another 100 years. When you look at the map of the United States and the thin line of the Northeast Corridor, you realize how much depends on this one small stretch of track. It is a vital artery, and right now, it is dangerously narrowed. The Gateway project is the bypass surgery that will save the patient. It is a massive, expensive, and messy operation, but once it is finished, the entire country will breathe a sigh of relief. We are seeing a new era of American infrastructure. After decades of neglecting our bridges, roads, and tunnels, the sheer weight of necessity is forcing us to build big again. The $16 billion tunnel is the flagship of this new era. It is a reminder that we can do hard things and that we can solve the most complex engineering problems ever conceived. It is a monumental task, but it is one that New York and the rest of the country are finally ready to face. As the project moves forward, it will continue to be a source of fascination for those who love mega projects. Every stage brings new challenges and new solutions. From the freezing of the riverbed to the robotic installation of the tunnel walls, it is a masterclass in human ingenuity. And while $16 billion is a lot of money, the cost of doing nothing would have been much, much higher. The legacy of the Gateway Tunnel will be the millions of people who travel through it without ever giving it a second thought. That is the goal of great engineering, to be so reliable and so efficient that it becomes invisible. But for those of us who know what is happening deep beneath the Hudson, we will always see it as one of the greatest achievements of our time. It is a story of grit, science, and a refusal to let the future be dictated by the failures of the past. So the next time you see a train moving silently toward the Manhattan skyline, think about the $16 billion world unfolding beneath the waves. Think about the massive machines, the frozen earth, and the thousands of people working around the clock to keep the city and the country moving. This isn't just a tunnel. It is the $16 billion lifeline that is literally holding the American economy together. And it is finally, against all odds, becoming a reality. The final phase of the project, the renovation of the old tunnels, will be just as impressive as building the new ones. It will be a historic restoration on a massive scale. Workers will have to carefully remove the scars of Superstorm Sandy and restore the 1910 architecture while injecting it with 21st-century technology. When both the new and old tunnels are operational, the reliability of the system will be transformed. It will go from a system that is always on the edge of failure to one of the most robust rail links in the world. This is the power of a mega project. It changes the landscape, it changes the economy, and it changes our sense of what is possible. The $16 billion tunnel is a bold bet on the future of train travel, the future of our cities, and the future of human engineering. It is a massive undertaking, but it is one that will be felt for generations. As each concrete segment is locked into place, we are building a foundation for the next century of growth and connection. And that is worth every penny of the $16 billion price tag. The sheer scale of the equipment involved is something to behold. The gantry cranes used to lower parts into the shafts are so large they require their own foundations. The conveyor belts that carry the excavated dirt out of the tunnel stretch for miles, moving a constant stream of earth that never seems to end. Everything about Gateway is oversized. Even the bolts used to secure the tunnel segments are the size of a human forearm. It is a world where everything is built to be stronger than it needs to be, because the environment is so unforgiving. For the engineers on the project, the pressure is immense. They aren't just responsible for the $16 billion. They are responsible for the lives of every passenger who will use the tunnel for the next 100 years. Every calculation is triple-checked. Every material is tested in a lab, and every weld is X-rayed for defects. In a project of this scale, there is no room for error. The stakes are too high. But as the tunnels push forward, foot by foot, the sense of accomplishment grows. We are witnessing the construction of a landmark that will be discussed in classrooms a century from now. Just as we look back at the original Pennsylvania Railroad tunnels with awe, future generations will look at the Gateway Tunnel as a testament to our era's vision and skill. It is a monumental effort that will bridge the gap between our current struggles and a future of seamless, reliable, and sustainable travel. The deep earth under the Hudson is silent, but the work going on there is anything but quiet. It is a symphony of machinery, a testament to our will to overcome the barriers that nature puts in our way. $16 billion, 10 years of construction, and a century of planning are all coming together in two perfect tubes of light and life beneath the river. This is what it looks like to save a city's soul, and it happens 1 inch of rock at a time. The Gateway Project is the future, and that future is finally being bored through the bedrock of New York.